I'm here from Romania to speak about Vertex AI and how MLOps help us to actually build amazing pipelines and to put in production. My name is Marton. I'm Hungarian, living in Romania, and I'm actually very proud of me that answering a lot of questions on Stack Overflow. Probably use it, probably you have checked it out, and my contributions are there something very interesting for me, and I cover a lot about that. Based on that, I have a couple of memberships in different community programs, but I'm still a developer, a software developer back at Romania, and the company I work for has some offices also in Lausanne. So let's see today what's on our agenda. So we will see what is machine learning ops in a way, to see how we can adjust manual deploying models, manual training to actually make it automation of it. We will see what is Vertex AI, how to build, train, and run experiments on it, on top of it, and we will see how to adapt to changes of data, because pipeline needs to be triggered at some point with that. So, what is MLOps? MLOps is actually a stack, or it could be an notion for some code. But whenever we are actually developing machine learning system, it's not just the machine learning code. There is also data collection, data verification. It could be testing as well. But then there is the metadata management and the monitoring as well. Whenever we are dealing with machine learning code, we are already dealing with the full stack of the development. Often, you don't develop machine learning code without having monitoring, without metadata, because that means you are blind to what you have developed. You need to analyze it and you need to use it. So machine learning ops could be DevOps principles to ML systems. But it could be continuous delivery and automation pipeline for machine learning systems as well. In the end, machine learning ops, it could be 3 levels, or at least 2 levels, because manual is, let's say, not a level as well. But we can name it as a manual process, as a pipeline automation, and a CI/CD pipeline automation. Well, manual is one when you develop a model, you build it, you start it manually, you evaluate manually, and eventually you deploy it somewhere manually. Or even you are not deploying, you are actually running experiments by hand out of it. Pipeline automation is that when these phases are actually connected for you by turning on and running a trigger on the pipeline. CI/CD pipeline automation is when you develop code, and the code itself describes the pipeline. We will see what that means. Essentially, the release cycle on the manual path is infrequent, or at least there are no iterations. It's a manual job, and no ICD, and there is a huge disconnection between ML and operations as well. But when we talk about level 1 automation, we have continuous training by automating the machine learning pipeline. We achieve continuous delivery of model prediction. We automate the build, train, deploy pipeline, and the new pipeline mostly based on new data. So essentially, we need to understand that level 1 means that pipeline is based on new data. Level 2 is when you iteratively try out new machine learning experiments. I call it experiment because at some point it might get to production. And you continuously source code package or build source. So essentially, your engineers, your software developers, your data analyst is developing code. The code differences could yield to a better model. And that pipeline is triggering all these jobs for you. So you are building a source. What is source this time? It could be a container. It could be a different algorithm. It could be tuning a hyperparameter. It could be adding or taking out features. It could be data preparation of it. Anyway, it's a code. And normally when you, let's say, commit or there is an event that something has changed on this, the CI/CD pipeline, based on the source code, starts an orchestration experiment as well. By experiment, we need to understand that it could be, for example, an A/B testing. It could be a model that gets only 10% of the traffic in production. And once it has the monitoring up, you get the metadata numbers, you may switch and enable from 10% to actually even to 90% or 100% of the model. This could be also a canary release build based on the facts that you actually measure it. If I put out in an automation diagram of it, we will quickly see that the manual process is starting from here. Actually, you get a trained model, then a prediction service, and the prediction service is being monitored. Based on the monitoring, there could be a continuous training if there is new data out of it, and there could be also a script that actually automatically describes your script. When we actually go up to level 1, there could be automated pipeline. Automated pipeline could be based on new data or some new events for you. But this level 2 is actually the interesting stuff for it. Let's see the basics of it when I put some artifacts on top of it. So essentially, you have the training model somewhere here. Essentially, when you build out automation, you need to have a model registry. The model registry lets you to actually run versioned models and even have artifacts, metadata stored. Then you can go back and forth with the model itself. You could have a draft candidate and later a latest labeled model that you put it into production. All this could be with automated processing as well. Also on the monitoring part, there is the performance as well. Performance is, let's say it's not industry specific. You decide how do you measure the success of the machine learning model. Essentially, you have an object or you have a conversion rate that you measure business-wise, nothing fancy with machine learning, business-wise you measure it. And based on that, you could actually go back and forth with the model and automatically roll back or actually roll up. That's a feature as well, to roll up. Now, if we go out to the level 2, I added more elements to the chart. So essentially, the true data analyst and data engineer has data store sources. It has feature store. What these are? Imagine an orchestrated system. Imagine you are part of an organization, a company, where there are different roles. It could be someone who owns, let's say, a database. That database is too big, so you get to them and you request an export of that. But that export is essentially stored in a feature store, or it could be in a data store as well, and it's compiled for you only a subset of the information. That owner of that data constantly can update you that data source. The rest of the model is hidden for them. They just update the data source for you as well. And you get an event that the data has changed, and you should actually rebuild the system. Or the pipeline automatically rebuilds the system, and it will figure out if it's the evaluation process, let's say the accuracy of the model is higher, better, but there are other ways to actually measure a model as well. Also, you could have a separate team member who works with adding features, taking out, and actually data preparation and data validation for that. All these could relate to the source code and how do you package your pipeline, because one of the inputs to the pipeline is actually the data source of your inputs model as well. Good. This is the basic introduction to MLOps and actually to see the levels of operation they are running. Let's go to part 2, Vertex AI. Vertex AI is part of the Google Cloud Platform. It's a managed machine learning platform, so it means that you don't need to care of provisioning stack, provisioning VMs on it. It's for developers, or I would say for everyday developer. You don't need to be any specialization in order to run on this system. You can build, train, and also accelerate ML experiments. By accelerating ML experiments, it gives you tools that actually kicks in for you some aspects of it in order to better understand your model, to figure out where you can improve or figure out what's the plus of the model and you need to eliminate from the model as well. My favorite feature of the Vertex AI service is that it can deploy models as a REST service. So even if you have built out some model, it's automatically deployed like a REST service, like a website, and so on. So that's the feature I really like. Good. So what's included in Vertex AI? Vertex AI is a huge platform. So as you see in the image, it has a lot of components. Essentially, on the top, you have different ways to actually how you create your models. I will start with the custom models. Essentially, let's say that you could have a container, you could have a model built out based on any framework that you develop, and you package it as a container. Then there are AutoML objectives. These objectives are for non-techie people, let's say so, that they can use the managed objectives of the platform, and simply they need to format the data into a specific format, upload it, and the tool will automatically train for them. Then nowadays they added in preview BigQuery machine learning part of the Vertex AI. Not sure if you have used BigQuery. It's a warehouse and based on structured data, it can provide you machine learning models. They offer like 30 models out of it. In a nutshell, you know, in SQL language, you have the syntax create table, rest of the columns. BigQuery offers you the syntax create model, type of model, what are the include columns as a select statement, and essentially it will not create a table like that. It will build out a model which could take 8 minutes, 10 minutes, 6 hours based on data volume and the model complexity as well. Why it's important that they added BigQuery and machine learning? Because a lot of organizations, a lot of companies have data in structured format, in tables, or in raw flat tables. And they often run automation out of it, machine learning operations. And if it's part of the Vertex AI system, it means that it can be consumed and automated in a pipeline as well. It's in preview, so it's you need to sign up with a form and you get it the features as well. Essentially, we need to understand that the data set is the one that actually starts the whole process. Then there is the training. It builds out the model. The model gets an endpoint. Then there is a prediction itself. But there is also model monitoring and some metadata attached to the offering as well. Also, you could have defined experiments. The interface helps you to actually manage these experiments. You have some advanced tools like Vizier, AI accelerators, explainable AI for data analysts and data scientists in order to actually see what part of the model is underperforming or what is the essential way. Like in a nutshell, let's say that you took a picture and the explainable AI could actually say that this part of the picture is actually the interesting part, the rest of the part is not interesting in the model. And you will essentially understand that you need to improve the data input, that you have to add additional parts of data input to be considered and relevant to the model as well. That's a basic example in a nutshell. Essentially, all this is connected in a pipeline. So, for those who are first to Vertex AI platform, you don't need to be in the Google Cloud with the project. It could be your project where it is on-premise or another cloud. Vertex AI can be consumed as a REST service as well, and I suggest you should try it out. We at REA are using like this the project. Often the projects are on Hessner servers, and we actually use the stack of the Vertex AI to run the machine learning jobs as well. So, Vertex AI is a serverless platform, of course. You are not deploying a function, you are deploying a model as a service. You have open SDKs, and of course you are paying only for usage. So it's different model. As you know, probably the serverless model is how the billing is set up. That's an operational model for them. So Vertex AI use cases in a nutshell, because it will be too many items on it. So you have here the AutoML objectives or your custom models. You could have BigQuery. Essentially, this builds out your objectives and data sources. It comes to the Vertex AI platform for training. It gets a model. Then you deploy to what it calls Vertex AI endpoints. This is actually the REST endpoint service that you are going to consume on a computer. Some managed dataset and objectives are in the image, tabular, text, and video classification. Let me switch to the screen in order to show you some of this here. So essentially, this is the home screen of the Google Cloud Platform. It has been recently revamped after Google I/O. You can quickly find here all the elements that you frequently access it. If you add here in the search the Vertex AI, it will open up the platform for you. Vertex AI, it has here a basic dashboard, but dataset is the one that's important. If you go to create dataset, you are able to choose from tabular, text, video objectives out of the box for you. You could have a single label, multi-label, for example, image. You could have for tabular data regression or forecasting. For text, you could have single label, multi-label. Actually, this multi-label stuff is 99% used on our projects. So whenever there is a new machine learning project, usually this multi-label stuff is always included somehow. It depends all the operation and the entity extraction. So every company has some document processing or some structural data that needs to be processed, and it's important. And there are others as well. What I want to show you is that they offer an interface to actually label some of your data. What you see here is label classification for images, but there are interfaces for also text classification. Text classification interface, it means that there is the bunch of text, and with highlight, you could highlight the brand, the price, the attributes of some of the text out of it from the interface as well. So essentially, if you are new to this and you have part of your company labeling task, turn to this platform and actually use it out of the interface as well. What you see here, just a basic example, is that there are some images of flowers uploaded, like 600 images. I've trained the model. There are some others here. This is the trained model for the platform. The training for that model took 28 minutes. And let's see a demo, because I created an interface where you have some photo, and actually when I hit here predict, it will do a REST API to the endpoint, so there is an URL for the deployment, and it will return you the respective objects for it. So the confidence for here is 100%. It's a rose. Let's see the sunflower. Yeah, it's not like that. It's machine learning. So people ask me, what's the latency of here? I would say usually 1 to 5 seconds. It could be made faster with intensive cachings as well, but usually the trick here is to do batch processing. So Vertex AI supports you batch processing. Like BigQuery doesn't support batch processing. There needs to be line. But if you exported the BigQuery model to Vertex AI, you could have batch processing as well. And that's really helpful. Okay, so I put here also a dog as well. Let's see what we get based on the dog. Well, the dog is not a dog. It's 89% of tulip. Essentially, what I wanted to show you is that probably you already know that when you are training a specific objective, you need to train a generic label, like not a label or an outsider label of everything else, or at least as your new data is coming in and it's not a match to your objectives, you need to train that that's an outsider. And this is a process to actually help people to maintain a better model. Here, in my case, this is not the case. I didn't add let's say, a not classified label to it, but that would be the next step of it. Good. Let's go forward. So, what we have here, how that was built, based on I uploaded folders of images to cloud storage. Yeah, hold on. I uploaded to cloud storage. Then I chosen image classification multi-label. I used actually the JSON notation. So whenever you upload from the cloud storage, you are able to create a JSON file, and there you describe the labels. I didn't label 600 images on the interface. The interface is just helping you out in case you need it. And then you actually get the model and get to the endpoint as well. REST API was consumed by whatever demo interface I've used it. I've already shown you this. It should not thank you. Why it go to the end? I should probably. So Good. So that was the short introduction to Vertex AI in order to show you what are the capabilities. I focused only on managed models, but you can bring your own custom model. You are actually able to actually run your model, not from this interface, by using training jobs and automation with the pipeline, and that is the next section of it. So essentially, pipeline connects all the operations of Vertex AI platform and other subsystems as well. Why are pipelines useful? Essentially, it lets you to orchestrate things. I often run machine learning jobs part of a team. And when there is, let's say, a junior developer, they are tasked only with one step. And whenever I need to actually change something, I know that I'm in an orchestrator way. I have a repeatable, verifiable, and automatic process to make any change to a production model. So they change something, and I know that I can run the pipeline for it. Also, it's developing independently. It's very important to develop independently because you may have, let's say, a remote team part of it. Like there is shortage of data scientists, there is shortage of data analytics. But let's say far on the continent, either west, either east, there could be people tasked only for that feature. And you just are the, let's say, the team running the team or running the deployments and serving the predictions as well. Good, pipelines, because that's the topic of today. So what we have here, first on the image, I will walk you through the whole image. Essentially, there is a pipeline that will get the data. The get the data, it means that we set up a folder or we set up a database. It's where the source of the data is. When the data process is running, it creates two artifacts. One is the training data set, let's say 80% of your data, and another artifact. So these little icons here are artifacts. These are the evaluation data of the input data. Based on that, there is a training process, and the training process, it produces you a model itself. So this is a model artifact, what you see here. The model artifact, based on the evaluation data, is being evaluated, and we create metrics. We expose these metrics. These metrics are part of the developer. The developer chooses what are these metrics. It could be accuracy. It could be any label that you define it, any custom attribute of it. It could be runtime. It could be different objectives for it. Now, when I turn to the code, I know that this is a Java-focused conference. I have here Python example. It's much more easier to show on the conferences. Java code would be 150 lines of it, but it's possible to do it in Java as well. There are components. So just for explaining purposes, let's use pipeline defined in the Python as well. So essentially, there is this decorator in order to detect that it's part of the Vertex AI system. You have three functions, creating the dataset. The dataset output, you see here the variable output is being passed to the training function. Then the eval model gets the model itself. I should have, the model is here. The dataset of the test is there. Essentially, this defines a pipeline. The pipeline is being output as a JSON file. So Kubernetes, serverless, YAML, this kind of all the pipeline is being outputted, compiled into a JSON file. Essentially, this JSON file is the one that you are going to use as a trigger phase from the pipeline. So this second section from the code is when you execute the JSON pipeline. And now, let's go back to level 2 automation that I've discussed earlier. Essentially, you can generate this JSON pipeline, and that's the source code CI/CD machine learning ops. This is just setting up the basic example, but essentially you can automate that when there is a new change in your source code, when there is a new data, new event, new something, you compile the JSON file, and based on the JSON file, the pipeline will start it. Let's go further. So essentially, I've shown you the pipeline for gathering training data, and now let's say deploying. So the same concept with different operations. You have the create, we have the training process, we have the model itself, and now I added a section, part of the pipeline. I created an endpoint. This is the REST endpoint where Vertex AI stores and will serve the model for you. Essentially, this endpoint, you set here the machine, the scalability information, the number of, let's say, CPUs, RAM, these kind of options you can set, and it gets an endpoint. Region, of course, because it's cloud as well, and the model is being deployed. In the right, it's a new set of code. I want to show you that there are different sets of code as well. There are libraries for Google Cloud Pipeline components. These components are offered for you in order to make easier integration with Vertex AI, and you are able to actually do AutoML operations. Like you can, for example, have image dataset create operation and auto image training job run operation. These are offered by the components itself for the managed datasets that I've shown you previously on the screen. And of course, it's being compiled to a JSON file, and the pipeline job is being triggered based on the JSON file. Again, the JSON file could be spitted out by a different system. It could be part of a GitHub repository. It could be part of a GitHub action, automation, and whenever there is no new JSON file, the new pipeline kicks in. Good. Oh, yeah, components. So essentially, in the manual, there are different components. Vertex AI is just one of the components. They are BigQuery machine learning components as well. They are hyperparameter tuning. You can actually do iteration of it in your pipeline in order to try out multiple models parallel in a way. You have the batch prediction. You have the custom job. Well, this is usually the one that when you have a custom model, you need to use the custom job to feed to the Vertex AI system how it should train the model. Essentially, it's a container. And it will ingest the container, it will scale the container, it will train your job with it. Whatever you put in your container, it's up to you. And data flow, data proc, these are Google services in order to prepare some of the data as well. On the right, I added in here that currently they offer SDKs for Python, Java, and Node.js. So it's not just Python. I was in Poland last week with the same set of presentation, and one of the interesting questions was that what language should we use for machine learning system to develop? And I say, the language you know. That's the first choice. If you have the library for it, go for it. Otherwise, if you are not in these languages, go with Python. Good. And just in a nutshell, I've shown you gathering training. I didn't show you evaluate and scalable deploy a model. Pipelines can get bigger, can look like a workflow itself. So essentially what we have here is that there is an eval function. The eval function is checking if it meets the criteria that we set. Let's say 97 accuracy. If it's more than 97 accuracy, it could be an experiment that came by with a model. If it's more than 97%, it will be deployed. Otherwise, it won't be deployed. So this can go like a workflow system as well because it's a pipeline. It has operators in order to have these operations for you. I'm not explaining the code section as it. Slides are available on my SlideShare if you want to check it out. And I've included here the GitHub links in order if you want to try out and play with this. Good. Developer-friendly components. I really like this system because it's fresh on the cloud market. Google Cloud actually reinvented the wheel. It added, let's say, developer-first options. It helps me as a developer to actually kick in and run machine learning objectives for it. I repeat that you can have your custom components. And essentially, this can be used by your pipeline. I didn't mention that the pipeline has a caching functionality. So if you have, let's say, 15 steps of it, and you change only step 8, the rest of the pipeline won't rerun, only after the change of it will run it. That actually saves you money, and it saves you in speed of the whole building of the whole machine learning job for it. And in case you are very, very deep in the service, you have the metadata, artifacts, lineage stacking, inverse of pipeline DAG, and all these operations as well. As a recap, so there are data sets, either custom, either from your data sources. It gets trained, we get a model, we have an endpoint like a REST service, we get a prediction out of it, we get some metadata out of it as well, and we have orchestrated this using the pipeline. Now, part 4 is actually, let's see how we turn it on or kick in the pipeline itself. Essentially, just 3 ways I'm covering right now briefly, because I want to briefly cover this. So right now, you basically could be like a scheduler. Every day at 9 a.m. should build a model. Or I would say inverse. At the end of the day, the developer during the day works on a model, works on a new data set, but we know that machine learning build process is taking several hours. So essentially, you could set up a system that at 7 p.m. or at 9 p.m., it will rebuild overnight the model. So whenever next time comes to the office or logs in from home office, it will see what's the baby conceived yesterday and what's the new take, and they analyze it for it. So that's a scheduler-based launch process for it. You have a pipeline, you just kick it in and launch it. Then there is cloud build. Cloud build is actually to build containers per se, but can be used for all kind of shell operation automation. So whatever is a shell command and can be automated, it can be built by the cloud build service. These are services of the Google Cloud Platform. I forgot to mention it. So it can detect a change in the code base. It can trigger based on some processes, and it creates an image. So the container is built on an image, and the image could be deployed, or the image could be part of a pipeline. So here again, the pipeline could have 15 steps, and one step is, let's say, custom job with your own container. You need to build a container, so essentially building out the container and signaling the pipeline that, hey, a new container has been built is a CI/CD or somehow a CI/CD operation of that. And nonetheless, EventArc. EventArc is a new product offering of the Google Cloud Platform. It's like, I'm in Switzerland, so it's like a Swiss knife thing of the cloud. Like, it can emit all kind of events that you can imagine of the cloud. And it can detect changes on data. So in a nutshell, whatever leaves a log information, it's a source of event. So if you log something that it happened, EventArc can pick it up and trigger an automation for your events. This automation should be should be picked up by a small orchestration systems. And those could be cloud workflows. Not sure if you have heard about cloud workflows. Essentially, it's an automation service out of the HTTP concept. So whatever has a HTTP endpoint and can be called by a HTTP, it can be automated, not just inside the cloud. It could be SendGrid, it could be Bitly shortener, it could be Twilio, it could be different services as well. Essentially, you could set up a little cloud workflow that will get the event, and it will start assembling your pipeline and will run the pipeline. Good. I think that concludes all the parts of the pipeline world and machine learning ops. So let's see some conclusions if I get to that screen, or it's working right. So Vertex AI provides you an enhanced developer experience. You can build with groundbreaking tools that actually power Google. It's approachable for the non-machine learning developer perspective. You can have AutoML models, manage models, training. It eases the life of a data scientist because it can focus on one job. It can provide to the people that step is done by them. The rest of the people will integrate on the pipeline for it. It has an end-to-end integration with build pipelines, and it has a GitOps-style continuous delivery with cloud builds. I've explained that, and it has visualize and track experiments using explainable AI, TensorBoard, or Vizier, this kind of operation for that. So essentially, this concludes my talk about pipelines for your machine learning ops workflows. You can check out my articles as well, because I've written something on Medium Wall as well. And on Twitter, you can reach it out with questions, or I can show you some examples as well. Thank you for being here. If there are any questions, I'm happy to take it. Yeah, there is a question up there.
Hi, thank you for the talk. One question regarding predictions and serving the model. Is it possible to have serverless online predictions in using the Vertex AI platform?
There is not yet this feature, but it's been worked on. I have heard of it. It's one of the top requested feature right now. The prediction itself is up 24/7, but there is a solution right now. If you know Cloud Run, that's full serverless. It has a scale down to 0 billing model, and you can export. So I forgot to mention that you can export the models. And you can export the model, what the Vertex AI platform is actually built out for you, and serve the model using the Cloud Run interface. Actually, the demo that you have seen briefly today is running on Cloud Run. So the interface itself is on a Cloud Run. It's getting the model out of it, and the endpoint as well. So you have two ways to actually deal with it. But your request is very, very known. And it's a high-voltage feature that they should offer, let's say, scale down to 0 model, because that's serverless nowadays been. Yeah. Any other question or follow-up? Yeah, I didn't see you, but eventually they can.
I'll just shout loudly from over here. So is the intention of Vertex AI that you would host your models like to the public using that RESTful service? Like if I'm building a web app that has some machine learning component, would I have my front end communicate directly with Vertex AI, or is the intention more to export the model and to build some other service around it?
Yeah, it's an interesting question. The question was that is the intention of the Vertex AI system to actually serve for front-end use, or make it part of a backend? Well, essentially, prediction is not that fast in latency that it can be served by a front-end. So it's not like that. For this, it should be part of the backend system, or the front-end system should be adapted to actually have that latency of information. The other is that you need to build a full architecture in front of it. Like exposing the endpoint, we had the security talk. It's not advised, so you should build out an API in front of it. You should have authorization, authentication, even if it's public free, but they should get an API key, because that way you can measure the outsiders. I'm not saying that the outsiders you can measure, and you can shut them down for it. And you can leverage caching, because right now it's counterintuitive to actually run every front-end operation during the backend. So you need to do, whenever there is a prediction, you need to heavily cache it for the front-end. So we have, for example, large caching nodes, because the predictions, let's say, are limited. And they not always need to touch the prediction model, only when the model is updated. So you need to have a caching tier, and that caching tier serves before actually reaching the prediction service itself. Whenever we have rebuilt or deployed the model, we invalidate the cache, and they tend to build out this operation. So it's a lot more stack components than actually the good use. But let's say if you are new to the machine learning business, it's a fast track operation. Like you can get online in an hour, except the training phase, because I don't know what kind of jobs you are training. That could take individually 8 hours. But essentially, with the old process, you could get online in 1 hour. And that's hosting a machine learning model, not the personal blog. So it's living different era. And you don't need to be, I don't know, deep in Python or Java developer for that. You just copy-paste some recipes and you put it together, the system. Hopefully this answered the question, but I would love to talk this through with you because you may have an interesting feedback about this. There are two. Yeah, there is a middle question. I briefly see him. I can't see you because I'm not a rock star, but it feels like with this 3 likes actually. Yeah, go ahead.
So I have a question about data pre-processing pipelines or parts of the pipeline. So usually an ML system does do some data pre-processing. And on the one hand, how can you take that into account when serving the model actually? Because it's not only like the same picture, but you want to do some pre-processing, maybe some sharpening or whatever. How is that taken into account? And on the other hand, in the training set, in many cases, the training set doesn't change entirely. You just get new instances to the training set. Can you make sure that the pre-processing pipeline is only applied to the new part? For example, if it's very expensive to run the pre-processing, is it data addition compared to data change? Like these two parts, how does Vertex AI cover that?
Yeah. So it's really interesting. So let's go step by step. I blocked. What was the first part?
About data pre-processing and prediction.
Yeah, data pre-processing as well. So data pre-processing should be considered outside of Vertex AI platform in a nutshell. Like you could run a data flow job, you could run whatever data prep operations, and you store it somewhere. When we are talking about the artifact, I mean the task of the prediction image, let's say that you need to normalize it, you need to get the size, exactly the size of the prediction, you need to get into the same normalization phase. That can also feed it in the same process, like you have a microservice or you have a function, you have a container library that takes the same code to actually pre-process it, and also for the pipeline, for the prediction service itself. Offer it. So Vertex AI, it helps you to actually see this as a step and not interfering with how you approach this. They are the standalone cloud components apply. So essentially, you need to be with much more things in the cloud to actually run all this as a step. Otherwise, you need to build out also in these containers as well. So it's not quite interfering you, but it doesn't give you quick shortcuts in order to run it. The only shortcut I see is running the prediction itself. But you need to feed the right data to the model because the model is agnostic to them. So you need to pre-process the image as well for the prediction services and not just take a picture and use the other phone, take another picture because that may have different sizes, different approaches for that. So that's how I see this, what you have named this process as well. We have used recently for the structured data, we have used BigQuery offers functions right now. So you could, for every row of the data, you can have a function out of it. And it's being called that function, and it pre-processes that data. And that function can be also used by the prediction service. Whenever there's new input, that same function uses also for the prediction service. So even the training and the pre-processing gets to the operation. The second part of the question was like, how do you run for the new set of it? Well, I honestly don't know that answer. So I always rerun for the entire data set. I'm not aware of a way that you have 20% new data and you can run it for that. It's showing me that time is over. I'm happy to take questions. I will be at the corridor. So let's follow up on this. Thank you for being here. It was awesome to actually talk about these amazing things that cloud and machine learning let us to do that. Bye.